Mars seems to be on everyone's mind these days. NASA wants to send humans to the Red Planet by 2030, and SpaceX wants to get there sooner, with plans to receive humans by 2024. Mars is a favorite topic in Hollywood, with movies like The Martian showing what we might find once we get to the Red Planet, but most of them don't address the biggest questions once we get there. How do we survive in the long term? Mars' atmosphere consists mostly of carbon dioxide. The surface of this planet is too cold to sustain human life, and the planet's gravity is no more than 38% of Earth's gravity. In addition, the atmosphere on Mars is equivalent to about 1% of Earth's atmosphere at sea level. This makes access to the surface difficult. How will NASA get there? How can we have hope of surviving under such odds? What will happen after reaching Mars? NASA is already studying what kind of habitation we'll need to survive on Mars. 6 companies began designing potential habitat prototypes in 2016. All of these habitats likely have some things in common. They should be self-sufficient, sealed against a thin atmosphere, and able to support life for long periods without support from Earth. To get an idea of what to expect, consider the International Space Station. The International Space Station has really taught us a tremendous amount of what is needed in a deep space habitat, Davis said. We will need things like environmental control systems, life support systems, ECLSS, power systems, docking ports, and airlocks so that crews can take tours into space to fix things that break or to add new capabilities. Expect large, powerful instruments to travel across the stars to Mars during the first manned mission. Whatever the use of astronauts must be on a long flight. Davis also asked an interesting question. How much space is needed for each crew member? Can you imagine spending months in one place, surrounded by the same walls day in and day out? How far apart do they have to be to keep the claustrophobia at bay? In the days of the Space Shuttle, missions were 7 to 15 days, and there wasn't a lot of room for each crew member. On a space station, where crew members are on board for a longer period, usually 6 months, we find that crew members simply need more space. Based on this logic, it is possible that habitable bases on Mars would require more space for the inhabitants. Growth and persistence. Maintaining stocks of food and medicine on Mars is the best way to make habitation self-sustaining, but with a thin atmosphere and low sunlight, it can be difficult to get anything to grow. Synthetic leaves, designed to operate in harsh conditions, can offer a first aid solution. The sheets, made of silicone rubber, can take a little sunlight and convert it into enough energy to fuel the chemical reactions needed to make medicines and other compounds. The device harvests solar energy and retransmits it into the wavelength region, which is useful for the chemistry inside the channels, said lead researcher Tim Noel, associate professor at Eindhoven University of Technology. It has the ability to standardize reaction conditions wherever you are. That is, it can use sunlight during the day on Mars, despite the potential exposure to harmful ultraviolet radiation. The channels inside the shutter are protected because your device can re-emit the energy it collects at a safer wavelength, allowing any chemical processes to take place. This could be useful when the radiation on a particular planet is very active. And since light is essentially ubiquitous, this energy can be used to start making the molecules you need, be it medicines, agricultural chemicals, or solar fuels. Currently, methylene blue is used as a photocatalyst for drug production. The catalyst's job is to speed up the reaction, so the methylene blue color allows scientists to produce drugs faster than they could without it. Tim and his team are now working hard to make a variety of reactors. They hope to get the device on the flight to Mars. Nature has given us the perfect tools to survive almost anywhere. They just need a little bit of tweaking to survive off Earth. Reclamation. The exploration has an indication that humans are creating another planetary body, like Mars, that is similar to Earth, Davis explained. But really, it's about humans changing their environment to make it more supportive of our needs. This means that the first few trips to Mars should include only the essentials. One of NASA's first goals for its astronauts is to learn how to live on this planet. Since it is so different from Earth, survival is an important skill for astronauts to master. The initial base will likely include a habitat and a science lab. The interior of these modules will be very similar to the space station, but there will be differences. An example given by Davis is preventing toxic dust from reaching the habitat and laboratory. Microbial life is another threat to astronauts. Without further research on the planet, NASA cannot say with certainty what dangers could threaten human life. With this in mind, all scientists involved in the Mars mission will consider these and other potential risks. After the NASA base is well established and the astronauts learn the basics of survival, things get more interesting. After all, it costs a lot to send things from Earth, so we have to do farming on Mars. Such a farm would be greenhouses to protect plants from the challenging Martian environment, Davis said. It must be taken into account that the soil of Mars is not like the soil on Earth. The soil on Mars lacks the organic matter and putrefactive biological matter that plants need. It's good for you that they contain the minerals they need. Davis said his team calls this regolith soil and will need to purge it of some of the toxic materials. And NASA scientists can get the job done. Toxin-free soil isn't the only thing astronauts need to grow plants. But they certainly needed to use the water from the ice-covered poles of Mars. Many expect the first human base to be next to billion-year-old ice deposits, so that humans can easily produce the amounts of water they need to support water-intensive activities like agriculture, Davis said. So far no word on which electrode would be most useful, if there is a difference at all. It is expected that future Mars farms will be equivalent to greenhouses here on Earth. This is how people control plant growth. However, while plants will need higher pressure to grow, plants do not have to be at such pressure as the pressure in the ground. We can pressurize the greenhouse with carbon dioxide, which is the main component of the Martian atmosphere. This sounds like a win for both scientists and plants. Instead of having to wear cumbersome spacesuits, astronauts can wear lightweight oxygen masks. The basic idea is that Mars shouldn't turn into a second Earth for now, it should just work for NASA scientists to live and work. Perhaps in the future it could turn into a second planet. We hope Mars is just our first step into the universe. Once we dip our toes into the solar system, it will be easier to expand into the asteroid belt and beyond. Mars' low gravity provides an ideal platform for building and launching other vehicles into space. After we get a foothold, the only thing holding us back is our technology. Since technology is the Achilles heel of the mission now, we may have a way to get to Mars before we have a safe means of exploration. Those of us who grew up watching the Apollo missions, the space missions take off, and now the Falcon rockets climbing through the atmosphere will probably never see Mars colonized in our lifetime, but that doesn't negate the wonder we all feel every time we see one of those rockets soaring through the sky. It is not just a rocket, but a source of inspiration for future generations, perhaps one of whom will set foot on Mars.